I bet you, if you are a space enthusiast, you all must have heard about the James Webb Space Telescope. But have you ever wondered, what is this JWS? Don't worry, today we are going to know everything about JWS. It is the most powerful telescope ever built. It allows us to see farther into space, and further back in time than ever before. JWS is a marvel of engineering and a testament to human curiosity. It promises to revolutionize our understanding of the universe. JWST was launched on December 25, 2021. It is named after James Webb, NASA's administrator during the Apollo program. The telescope is a joint project of NASA, the European Space Agency, and the Canadian Space Agency. JWST is often called the successor to the Hubble Space Telescope. However, it is not a replacement. JWST observes the universe in infrared light, while Hubble primarily observes visible light. This difference allows JWST to see objects that are too faint or too distant for Hubble. Infrared light is invisible to the human eye. It has longer wavelengths than visible light. This allows infrared light to penetrate gas and dust, which can block visible light. This ability to see through obstacles is what makes JWST so powerful. It can peer into the hearts of star-forming regions and observe the first galaxies forming after the Big Bang. Infrared observations also allow us to study the atmospheres of exoplanets, planets that orbit other stars. By analyzing the light that passes through an exoplanet's atmosphere, JWST can identify the chemicals present. This can provide clues about the planet's potential habitability. At the heart of JWST is its giant primary mirror. It measures 6.5 meters in diameter. This is significantly larger than Hubble's 2.4-meter mirror. A larger mirror collects more light, allowing the telescope to see fainter and more distant objects. The mirror is made of 18 hexagonal segments. They are made of beryllium, a lightweight and strong metal. Each segment is coated with a thin layer of gold. Gold is an excellent reflector of infrared light. The segments are designed to work together as a single, precise mirror. They can be individually adjusted to correct for any imperfections. To detect faint infrared signals, JWST needs to be kept extremely cold. Otherwise, its own infrared radiation would overwhelm the faint signals from distant objects. To achieve this, the telescope is equipped with a massive sunshield. The sunshield is about the size of a tennis court. It consists of 5 layers of a special material called Captain. Captain is a highly reflective material that is also very lightweight. Each layer is coated with aluminum and silicon to reflect sunlight away from the telescope. The sunshield blocks heat and light from the sun, earth and moon. This keeps the telescope's instruments at a frigid -233 degrees Celsius. Section 5. Unfolding in space. Launching a telescope as large as the James Webb Space Telescope into space presented a unique challenge. You see, the telescope was just too large to fit inside any existing rocket in its fully deployed configuration. The solution? Well, it was to fold the telescope up like origami. Once in space, JWST underwent a complex and meticulously planned deployment sequence. Over the course of several weeks, the sunshield unfurled, the primary mirror segments unfolded and locked into place, and the various scientific instruments were powered on and tested. The successful deployment of JWST was a testament to the skill and ingenuity of the engineers and scientists who designed and built it. Section 6. Seeing the invisible JWST's instruments. JWST is equipped with 4 main instruments. Each instrument is designed to study the universe in a different way. The near-infrared camera, or NIRCam, is JWST's primary imager. It observes in the near-infrared wavelength range. It's used to study the early universe, star formation, and exoplanets. Then we have the near-infrared spectrograph, or NIRSpec. NIRSpec is a spectrograph that spreads light out into its different wavelengths. This allows astronomers to study the chemical composition and physical properties of objects in detail. Next, there's the mid-infrared instrument, or MIRI. MIRI is sensitive to longer, mid-infrared wavelengths. It can see through gas and dust even better than NIRCam. MIRI is used to study star-forming regions, the centers of galaxies, and the atmospheres of exoplanets. Finally, the Fine Guidance Sensor Near-Infrared Imager and Slitless Spectrograph, or FGS NIRIS, helps JWST point accurately and track targets. It also has imaging and spectroscopic capabilities. Section 7. Journey to the second Lagrange point. Unlike Hubble, which orbits Earth, JWST orbits the Sun. It is located about 1.5 million kilometers, or 1 million miles, from Earth at a special location called the second Lagrange point, or L2. Lagrange points are points in space where the gravitational forces of two large bodies, like the Sun and Earth, balance out. This allows a spacecraft to maintain a stable orbit with minimal fuel consumption. At L2, JWST always remains in line with Earth as it orbits the Sun. This position allows the telescope's sunshield to effectively block heat and light from the Sun, Earth, and Moon, keeping the telescope cold. Section 8. Unveiling the early universe. One of JWST's primary mission goals is to observe the first stars and galaxies that formed after the Big Bang. Because light takes time to travel, looking farther into space is like looking back in time. JWST's infrared capabilities allow it to see farther back in time than any telescope before it. It can detect the faint light from the first galaxies, which formed over 13 billion years ago. By studying these early galaxies, astronomers can learn about the conditions in the early universe and how galaxies evolve over time. Section 9. Exploring new worlds. JWST is also making groundbreaking discoveries in the field of exoplanet research. Its sensitive instruments allow it to study the atmospheres of exoplanets in unprecedented detail. By analyzing the light that passes through an exoplanet's atmosphere, JWST can identify the presence of molecules like water, methane, and carbon dioxide. These molecules can provide clues about the planet's potential habitability. JWST's observations are helping us to understand the diversity of exoplanets and the conditions that might make a planet suitable for life. Please subscribe to our channel for more exciting content about the universe and beyond.